Hey everybody, welcome. In that new tutorial which show how to reproduce almost all the triggers that we have into the behavior editor as a chop graph. So please notice that this tutorial is using Golaem 8.2.2. This is where we introduce most of the new chop nodes which are going to be used here. And let's talk about the command setup that I'll have into all my scenes here. So I made a grid of characters. This is using the same entity type. On that entity type, I added just a Golaem attribute, which is going to be a value of float, which has 0 as a random default value. It's going to be called trigger out, and this is where we're going to output our channel graph. And then also I'm having a motion behavior here, which is going to be triggered by the various triggers that I'm having there. So that's my setup here. So let's see how we should tackle all those attributes that we have, all those triggers that we have into that list here, and all the operators as well. Okay, so let's get started with the random trigger. So the random trigger can be found at the beginning of the trigger list here. It's the dice icon. As soon as you hit it, you ended up with that node, which has two attributes: the percentage of characters that you want to return true, and isDynamic is a checkbox, which means that do you want it those 10% to be reevaluated at every frame, or do you want it to be fixed? So we'll just evaluate that trigger, see how those parameters works, and then we're gonna jump into the chops and see how we can reproduce it and even make it more powerful than the default condition that we have in here. So 10% means that what we're going to do is we're going to assign a number between 1 and 100 to every single character. It will be a random number, and we'll check if that number is below 10. If it's below 10, the trigger returns true. If it's above 10, it returns false. isDynamic means that we're going to reprocess that random number at every frame. So here, if we run the simulation, we'll notice that at every frame, there's a bunch of characters which are going through that trigger and returns yes, and you notice that after a couple of frames, all the characters finally will have a number between 10 and just to process this. So if I remove the isDynamic and play that trigger, you notice that even if I play the simulation for a long time, there's only a bunch of characters which will actually return true for that trigger. So that's 6 of them, which corresponds to 10% here of my 60 characters. Great. So let's disable that behavior for a minute, and let's jump into the chops and see what we can do to reproduce something similar to this. So I'm going to open my chop editor here. I set it up an output node, which is writing into my out attribute, and let's see if we can reproduce. So the first thing we want to do is probably like pick a number, a random number between 1 and 100. So to do this, we've got the operator, mathematical operator node. It has a list of all the operations which are available, and one which is available is rand. If we were looking at the documentation, that rand will take a value between a range, so a minimum range and maximum range. So we need to connect that operator with some inputs where we're going to provide this. So let's rename that rand between 1 and 100, so it has some meaning if we need to jump this afterwards. So this is going to be our constant 1 here. So I'll set it up to double. I can rather write 1 here in the expression or 1 into the driven attribute there, so it doesn't make any difference. So it's going to be constant 1 there, and I'll do something similar for 100, so constant 100. Great. So if I connect those together and connect this to the output, we can check that here all my characters, they end up with a number which is going to be comprised, so that's going to be a double number, which is going to comprise between 1 and 100. If we were throwing the frames, running the frames, you'll notice that that value changes all the time. So at every frame, we pick a different random number for every single character. Great. So next, if we want to reproduce the fact that we want to return 0 or 1 if it's above a defined threshold, this is up to us to add a couple of nodes to tackle this. So first I want to define my random threshold, so the 10% that I had before in my previous example. So let's name this rand threshold, set it up to double, and set it up to 10. 10 meaning 10%. And finally, what we want to check if it's that random number is going to be comprised below the threshold that I've been fixing. So finally, we can just use the Boolean operator and just check if this value here, that random value, is below that threshold I've been defining, and write the result as my trigger out attribute here. So now I can check. Now it returns 0 or 1 in some situations, and if we were looking at all the 1 value, we probably notice that we just have a bunch of them. So maybe what I can do is retrigger my motion behavior. Sorry about that. And instead of using the result of the 10% trigger, what I'll do is I'm going to check if my trigger out value corresponds to 10% and run my simulation to see if I get something similar. So when the simulation starts, you notice that well, there's probably like a, yeah, wait a minute. Here, this behavior there has the same color than my walk behavior. So let's color it as yellow. Okay, so now you notice that frame after frame, more and more characters switch to blue, blue meaning it's the color of the motion behavior. And if we were about to play that behavior long enough, we'll notice that all the characters go through those. So looks like it's working. We've got at least the same setup than 10% dynamic. So what about that is dynamic box? How do we reproduce that is dynamic box? So remember what I was saying here is that random behavior, that random operator, what it does, it changes the value at every frame. So probably what we want to do, if we don't want it to be dynamic, is we want to be able to keep it somewhere. The first value which is picked, we want to pick it, and this is the one we want to use. So there's different ways to do this, but one way, probably the most simple one, will be to use the Accumulator node. That you can see that Accumulator node can remember previous values that he had. So first thing I can say is I want to just remember one value. And it has also two strategies. Either by default, it just remembers every time the new value which comes in. So all the old values which get stored, every time there's a new value, it gets out, the old one. So we can invert that behavior and say, well, we don't want it to be first in, first out, which means there's a value at frame 1 which will come in, then at frame 2 something will come in, so value at frame 1 will be removed. So we don't want this, we want the value at frame 1 to be kept. So we're going to remove that first in, first out checkbox. And now if we run the graph, pick a character, we'll notice that my random, let's go back to the previous frame. My random number here is going to be 67 for that character. It will be remembered there. And at next frame, even if the random value changes, we can see that we've been remembering only that first value that we had into the system. So if we were looking at the simulation, we would expect some characters to be turning blue because those guys will end up with a value which is below 10%. So now we're having 4 characters which are running that motion behavior, and we've been reproducing that is dynamic node. If we wanted to go, oh wait, it's not dynamic node. If we wanted to go, is dynamic, or if we don't want that node to have any influence, we can just check in, first out, and now every frame it will change, the value will change, and we'll have all the characters turning blue at some point. Okay, that's for the random trigger. Let's see the next one. Okay, let's continue with the frame trigger. You will see that this trigger is pretty easy to understand and reproduce using a chop graph. So the frame trigger is the second one here in the list, and you can use it to define if you want to evaluate the current frame which is running into Maya, and operate it, make a Boolean operator with a specific value. So here I'm asking when frame is 20, I want my characters to start walking. So let's launch the simulation, and you notice that at frame 20, every single character switch to blue and start working. Great. So let's see how we produce this using a channel operator. I'm going to open my graph. Once again, it's going to be written into my trigger output node. And what I can just do here is drag and drop a chop input node. And within the various expressions, you notice that right at the beginning of the channels which are available, you got a currentFrame. So that currentFrame will return the currentFrame, obviously. So it will read that value from Maya for you. And what we can just do is, well, let's check what it returns. Let's disable this for a minute. Let's disable that motion behavior. And let's see what's returned as a value into the attribute. So let's open the spreadsheet, and we'll notice that here the value for all the characters is going to be 23. And it runs and evaluates. So far so good. So what we want to do is we want to operate it. So apply a Boolean operator. So I figured the Boolean operator from here. It has various operations available, so you can see all the values, comparison operators, and also some logical operations there. And what I want to do is compare it to a specific threshold. So that's going to be my frame threshold here. I'm going to set it up to double, and either I can write that value of 20 here into the expression or into the driven attributes. So what I'll do is I'm going to ask if the frame is equal to that frame threshold that I just defined, and return the result as a Boolean into the attribute there. Let's trigger that motion behavior based on when that trigger turns in. So here I connected the attributes into that start trigger. And here at frame 20, all the characters switched to the motion walk. So that trigger here, that motion trigger, that behavior time trigger, currentFrame trigger, has 2 units, either frame or seconds. So that's also something that you can reproduce with the channel operator. You may have noticed that within the expressions, you have 2 units to represent your time, either the current frame or the current time. So currentFrame is obviously linked to that timeline here, and the current time is just an abstraction which is not taking into account that frequency there. So yeah, hope that helps. And let's see the next trigger. Okay, let's see now how we can deal with the polygon zone trigger. So here I connected 2 geometries to that polygon zone trigger, which are those 2 geometries there. Set it up, so that's the default mode as 2D mode. So it means that we're gonna check for interactions with surfaces compared to 3D, which will be volumes. And I just let the other options the same way. So here that plane will be animated into my scene. So as soon as the plane moves, it triggers the character, and that one in the background is not moving. But as soon as some characters start being with that zone, they just get started. So let's see how we should reproduce this with a graph, chop graph. So starting from 822, we've been introducing the geometry input node. And it has different parameters. One is a list of geometry, which is kind of what we can replicate from the trigger. Also a mode. So here what we want to use is inside mesh 2D to reproduce the 2D trigger, or 3D to reproduce the 3D trigger. So I'm going to go with 2D here because it's going to be surfaces. And at the moment, it's not really easy to connect those 2 geometries with that chop graph. So I'm afraid I'll have to go into selecting the plane, selecting the geo there, and mapping those 2 together. We'll notice that as soon as, let's disable that graph for a minute, and let's enable that channel operator graph. As soon as I start the simulation, we'll notice that those guys there, for example, if we check, the geo input is returning 1 compared to those guys there where it's returning 0. Same goes for that character in the background, it's returning 1, and for that character is returning 0. And obviously, as the geometry will be moving, that character here, which used to return 0 before, now returns 1. So if we were connecting this to the trigger and re-enabling that motion behavior that I had, now we've been reproducing the exact same stuff. If we had geometry which were volumes, we'll just have to set the chop mode to inside mesh 3D, and it will replicate the exact same option than what we had here. But keep in mind that in addition to this, we can check if we are in multiple geometries. For example, if we want to check if we are in two zones at the same time, or in one zone and not in another. So we can combine those operators with more complex operation as always, because it's going to be contained into the chops. Okay, let's now see how you can convert the painted zone trigger as a chop graph. So this is how I set up my graph here. So start my motion behavior, and now it's been started by a trigger painted zone. In the trigger painted zone, you're going to select which zone you want to take into account, knowing that you can paint multiple. Specify a specific operator, a value, and a threshold. So here I compare, I want my value to be equal to 0 with some threshold in case of noise errors. And when I run the simulation, I can see that the characters which are only in the red zone gets triggered. So within the chops, I can bring a new input, and if I look into color as an input, I can see that I can look for the entity type color. I can take a look if it has a painted color, and if that painted color also it can return that specific painted color. So you can see the attribute, that channel, as a specific kind of formatting. We get this to say that the actual character, painted zone, or painted color, which will return a color. And you can see that in bracket, we got the painted zone name. So we're going to copy the name of the actual painted zone locator that we have in your scene, in which we've painted what we need. And I'm going to paste it on top of my bracket stuff. I can specify it's a channel if I want to. Keeping the auto mode should work. And if I connect this directly to my output, now I can check this character here, for example, run the simulation, and once again I need to enable my channel operator behavior. So my graph gets executed. So here it will return 0, 0, 0, which is the default value if you don't have any color behind you. So I can also combine it with the ice painted color if I wanted to. But I can rather check maybe what's going on here. So now that guy returns the color which is behind him. So it's 1, 0, 0. So 1 for the red channel, green channel in the second place, and blue channel in the third place. Okay, so once again, I can do a comparison if I want to. So let's compare it using a Boolean operator. Let's plug that Boolean operator in the middle. And I can use the equal operator there, and just provide a value. So compared to the trigger, the painted zone trigger, we don't have any specific color control here. We've got the driven attribute, which represents a vector, and this is where you're going to represent your color. So you have to know the RGB values of your color here to write them properly. So I'm going to put 1, 0, 0, which is what we've been seeing working so far. And once again, if I need to set up a threshold, I can put like I can probably have to rename those nodes. I can set it up like a threshold of 0.5. I can even set it up as threshold per value if I want to have a vector threshold. That's something which is possible as well, like 0.5, 0.5, 0.5. We'll have different values here and there. So now I'm comparing the value of what I can fill into the painted zone color with some constant, which is going to be red there, const red, and return this into my attribute. So let's check what we have. We've got that character which returns 0 because it doesn't have any color behind him, and we've got that character which has 1 and returns 1 because the comparison between the current color and the constant color that we've been providing is good. So let's once again plug it to the motion behavior and see what we get. And now we can see that only the characters which are in the zone gets affected by that color. Okay, let's now see how we should address the distance trigger. So, well, just a quick word about the distance trigger first. Here it takes a couple of objects. So objects can be whatever, which is a transform within Maya. So here you can see I mapped 2 locators in a geometry. And when those objects come in, what we're going to take is their position. So position is going to be, what's inside the transformation matrix, which is here. So more or less that translation, which is here. If that locator is within a transformer group, we'll get that global position, but that's more or less like a 3D position, and we're going to compare distance with. So great, and what we'll do is check if the distance is inferior to whatever value that we put here. So here we're going to check if we are less than 3 units away from any of those objects there. So let me run the simulation so you can see how it looks like. So you can see that locator there is moving, and as soon as it moves and comes close by less than 3 units than any characters, they start moving and play that walk animation. Here as well, I'm having a locator which is triggering all the characters around, and here I'm having a geometry, so we're taking the pivot point of that geometry, and that triggers those characters there. If we were about to reverse that trigger, we'll have all the characters which were not moving before, and as soon as that locator will move and goes away from 3 units to those characters, they start walking as well. Great. So let's see how we should reproduce this with the channel operator. So let's me first idle that motion behavior and enable that channel operator. And what we'll do is we're gonna bring a geometry input once again. So we've been playing with it when we were playing with the zone trigger. So here it mentions that it takes Maya geometry into account, but to be honest, you can plug whatever you want to, which is a transform. And here as well, it mentions like a mesh indication, but what you'll actually do is gonna compare with the pivot point, the same than the trigger operator. So what we want to do is to plug those there. So I'm gonna select them all, and I had a different version when I was doing the version with the trigger zone. So what you can actually do now in the actual release is you can select the geometry, press shift, it will hold the selection, and you can map those together, so it just avoids you going through all those groups and figuring out where is your actual chop inputs. Then it has multiple modes, so we can notice there's a closest mesh distance and farther mesh distance. So when it comes to distance, it's going to return an actual floating value. Then we got closest mesh position and farthest mesh position, which will return you the actual 3D position of the closest or the farthest meshes that we have here. So let's connect these two together and run the sim. So that's a distance here. I'm plugging this into, okay. So let's select that character here, and we can see we've got a distance of 3.99. So it's probably, well, I don't know, one of those locator or that geometry there. And as soon as this one moves, you can see that here it reduced. The distance reduces until it reaches whatever value which comes the closest. So great, we're pretty good with get the ID here, and once again we just have to make it as a comparison with an actual constant. So I'm gonna say if the distance is inferior to some constant value that I'm gonna put here, so let's cast this as a double and put my value there, then return the result of the comparison. And here we can see the value is 422, so at the moment says output is 0. And as soon as it's reached value which is below 3, it switched to 1. Great. So let's enable back my motion behavior, trigger it from the attributes, and now we can see we've got the exact same result that what we had before. If we wanted to invert the same way we've been inverting, I would just have to revert the sign which is here. So we'll have to put like a superior. Now all the characters are moving, and then those characters are moving as well as soon as the locator gets away from them. So just have a quick word about that other mode that I was mentioning. So here I've got the mesh distance. I can also get a mesh position, so the closest mesh position. And if I want to compute a distance, I'm not sure really what you would like to do it, but that's just, I'm going to say it's going to be knowledge here. What we could do is compare this with like a channel, which will be probably the entity position. Or maybe you want to compare the distance with something else than the actual entity position. So, and this is probably where you would have to know this workflow. But yeah, just, you know, knowledge. So, and what I can do here is compute the distance based on the mathematical operation. It has a dist operator. I can connect closest mesh position with entity position will return a floating value. That floating value here can now be put into my trigger comparison, and I'll have exactly the same result than before. So here the characters which were wait, it's not doing exactly what I need. Yeah, okay, that's because it's superior here, so let's say inferior to 3 units. Great. So now all the characters which are less than 3 units, then the locator, their influence, and then will work. So yeah, you know, once again, the ChOps allows you way more flexibility. If you want to build your own trigger, that's going to be the way to do it. So you can reproduce more or less all the nodes and probably derive from those nodes and create your own crazy ideas. Next, let's see how we should tackle the driven attribute trigger. So let's see first, how is it supposed to be used? So the driven attribute is a trigger which allows you to connect any Maya attribute into that attribute panel here and compare it with a specific value. So here in my scene, for example, I'm having that sphere on the bottom left here, which is keyframe animated. So the radius here is keyframe animated. So what I can do is I could link that radius keyframe to my driven shape trigger and use that to control when it's going to be triggered. So within the node editor, that's one way to connect the two together. I'm having my polysphere here with my radius attributes. So I can draw a connection. And in terms of inside connection, I can see I've got my driven attribute there. So I can connect those two together to make sure that it's working properly. I can check what's being read at the moment. So it's 0.481. And if I go into my polysphere, I can see that the keyframe value at the moment is 0.481. So what I can do is I can say, okay, when that value there is, I don't know, superior to 0.45, let's say, I want that trigger to return true, and I want my motion to start. So let's launch the simulation, and you can see that at some point here, my sphere grew big enough to represent more than 0.45, and then all my characters started at the same time. So we'll see that that within the ChOps, I can see exactly the same things and even more. I'll be able to even add some fuzziness into the game here because here all the characters start at the same moment, so I could fade that result, but I can also add some randomness as well if I wanted to. So let's jump into my ChOp here, and what I could just do is drop an input node. You may notice that within that input node, I have a driven attribute value, which is a vector by default, but it has exactly the same kind of stuff than that driven attribute trigger that I was looking at earlier in that video. So let's get into my polysphere here. Let's go into the node editor. Let's remove that trigger here for a minute. And let's bring instead, so let's select that node here, press Control, press Control there, and load those two together. So I've got my ChOp inputs, and once again, if I look at the inputs, I've got something called the driven attribute here, which is a vector. So I could take that radius if I want to, and connect it to the X component of my vector. So the fact that it's a vector allows me also to connect way more complicated attribute than just a floating value. If I want to connect a transform or whatsoever, I can have it as well. And then it's going to be really up to me to decide if I want to read it as a double or as a vector. So vector means that we're going to transfer only vectors through the chop pipeline, or double means that I'm just going to look at the double value of it. Great. So let's at least check that it's working properly. Let's connect it directly to my output there. And as usually, let's enable that channel operator behavior. Let's disable that motion behavior. And let's witness what's the current value here. So now I can see that as soon as that sphere is growing, we can see that the value is properly propagated to every single character. So they are reading correctly the value from the sphere and transferring it to the chop graph. So that's good. So let's say we want to do exactly the same thing that what we were doing before. Once again, it's just a matter of bringing a Boolean operator node, set it up to superior, and provide a threshold. So that's going to be my driven threshold. And I can set it up to double, either write the value here at 0.45 or write it there 0.45, and that will be exactly the same result. Let's drive my motion behavior based on that attribute rather than on the driven attributes, and let's run the simulation. So the value of the sphere grow, and as soon as it reaches 0.45, now all the characters move at the same time. So what if I want to bring some maybe randomness into this? Maybe one way I have is to define some interactive threshold. So the threshold could be different from one character to another. Maybe we can say, you know, I want for some characters to be a lower value, for some characters I want to be a higher value. So rather than just connecting directly as threshold here, I can do a more complicated expression using mathematics, using a ramp or whatsoever. So that would be one way to deal with this if I wanted to. As I was saying here as well, the driven attribute can be a vector, so I can also read the value from maybe a transform, like the position, the orientation, and do some specific computation based on this. For more information about the ramp, I just wait for that end of that tutorial where we're going to target that ramp trigger node that we're having and see how we convert it, and it will give you some idea how you can just change that graph slightly to have some more randomness here. Okay, next in the list is going to be the expression trigger. So you'll notice that this one will be pretty easy to convert because we've got almost the exact same controls directly in one node. So here I created an expression trigger in which I put a dedicated channel. So I ask to look for the entity index. So there's two different values in Golaem. One is the ID, which is going to be like a really unique ID, which looks like the first one is going to be 1001, then 2001, and so on and so forth. We've got a whole numeration there. And index is more something that you can handle, which is more like 0, 1, 2, 3, 4, etc., etc. So here I just ask for the index to be inferior to 30 degrees with a threshold of 0. So if I throw that simulation, I will solely expect to have half of my character, especially the ones which have low IDs. So this one is 12,001, which is probably index 12 or 11 if it starts from 0. So here I'm having half of my crowd moving, starting that motion, right? That threshold allows us to add some noise if I want. So let's say if I put a threshold of 10, it means that I'm going to look if the ID is comprised between or is inferior to 40 instead of 30 there. And now I've got way more characters. It's more if you want to compare something like a color and you want to allow some differentiation especially when you apply equal. Here, if you apply equal 30 and you put a threshold of 10, it means that we're going to look if the entity index is comprised between 20 and 40, and you have 20 characters switching to that animation. But keep in mind that the threshold will have to reproduce it into the chops as well. So let's jump into the chops. And in terms of expressions, I actually, when you look into the input node, we directly have an expression attribute there. And that helper, which can be open, allows you to bring the exact same channel list that we had into the expression trigger. So we can fetch exactly the same values there. And from that value, for example, we can look for the entity index. I'm going to load the input type to auto here, or I can say it's a Golaem channel. Doesn't make any difference here. And now what we're going to put into the trigger output is going to be that value there. So let's once again, let's open the, let's enable the channel operator behavior, obviously. And let's run the simulation. And now we can see that, as I said, start from 0, and that we got the list of the index being written into the attributes. So, okay, so far so good. So remember what we wanted to do is maybe to compare it to some specific values. So once again, when it comes to comparison, I can bring a Boolean operator. And what I can do is I can say, okay, if my ID is inferior to some constant value, so this is going to be my constant 30, I'm going to set it up to double, either write double 30 here or write 30 there, doesn't make any difference, and we're going to run the comparison here. And depending, where you are in the list, so the first 30 characters will be below the value of 30, so that will return 1, and the other one will return 0. So I can just replug this trigger here, which allows me to check the value of the trigger outs behavior and run the simulation, and now I've got half of my crowd, which is working. So remember, we are playing that with that threshold. So what I can do is have the exact same threshold comparison. So let's set it up to equals, for example. So if I do this, now I just have one character, which is character 31 of index 30, which is being triggered. Let's say we want to have a threshold of 10. It's pretty easy. You'll notice that here we can add as many operators, and if you look at the documentation, as many inputs, and if you look at the documentation of that Boolean operator, it will tell you that the third attribute you're going to plug in is going to be used as a threshold. So let's rename this threshold comparison and set it up to double and provide a value of 10. And next time we're going to throw the simulation. Now we've got our 20 characters running. Keep in mind, once again, as we're using the chops, all those inputs here can be dynamic. Here I put some constant value, but if you want to do some crazy computation before, no problem with that, and they can change per frame. That will be supported, and that will influence the way the behavior will be triggered. So once again, way more power than what the trigger can provide in some situations. Okay, let's see now how we can convert a behavior time trigger or a motion time trigger as a chop graph. So behavior time triggers are usually used to stop a specific behavior after it's been played for a specific length of time. So here I'm having the behavior time trigger. So behavior time allows access to just seconds and frame, which are generic duration times for behavior. Whereas you are also having the motion time trigger, which also express a percentage in addition to seconds and frame, and percentage will relate to the motion which has been picked for each character into the motion behavior which is attached to. So keep in mind that motion time trigger only works when it's attached to a motion, sync motion, locomotion behavior. So here we're having that behavior time trigger which has seconds and frames. So let's see how we can convert that. Well, let's run the simulation first. We'll notice that the characters are going to run for 50 seconds, and after 50 seconds they're going to end their motion. So let's enable that channel operator behavior, and let's go into my graph once again. So as always, let's drag an input, and what we can do is we can start typing behavior, and we have various kind of formatting here. So we got this dot in bracket behavior name. So when it's in bracket, we can feel that we'll have to rename this with the name of the appropriate behavior we want to look into. And we've got plenty of various controls that we can take a look into. So for example, we're having one which is called running time. So how long it's been it has been running for. So this one here is pretty convenient, and we'll have to replace that behavior name with the name of our crowd behavior motion. So let's replace that right away. Let's keep that channel running time, and let's connect this to my output, enable the channel operator so we can take a look at how the value is going to be evaluating here. So here we'll have the same value for the characters, and you'll notice that that value moves in time. So we got a seconds time there. So after frame 26, we had 1 frame. So it's been running for, that behavior has been running for 1 second. So okay, all good. Now we've got you know, the major piece of the puzzle. So here you can figure that we don't have any operators, but we can figure it's once the running time has been above a specific threshold, and that threshold is going to be that second here, or it's going to be the compilation, the addition of the two parameters there. So what we can do is, once again, drop out a Boolean operator, check if that time is superior to a constant, and once again here I'm putting a constant, but the ChOps allows us to put some pretty complicated value which could be different per character, so allows us to have more control if required. And we're going to set it up to double, set a value of 2, and write this down into the attribute. So let's see how the value evaluates now. So we'll probably have 0 for every single character until we reach frame 48, and at frame 48, oh, and obviously, wait, that behavior stops right before, so we never reached that condition. So let's go back to the default trigger instead. Here we go, let's go back. So okay, goes to 0, and then at frame 48, sorry, turns to 1. Right. So if we want, we can now connect that attribute together and use that attribute to drive the stop trigger of that behavior. So something which allows you also to have more control is the fact that here into the chop graph, we've been providing the name of the exact same behavior we're attached to, but if we want, we can also rely on the behavior, on another behavior of the graph. So if another behavior in the graph handed up, we could read that value, or if another behavior has been running for a specific amount of time, we can read that value and you know, compare it or do some crazy computation with this. So that's going to be for the behavior time, right? So we got another option, which is motion time. So let's see how this one gets tackled. So we've got a percentage here. So if I put 200%, it means that we're going to look how long the motion has been played. So after it's been played 2 times entirely, we're going to stop that behavior. So let's see what else we had in terms of controls if we had to do something similar. So let's go into the input once again and go into behavior, or maybe I should go into motion behavior, but maybe. Okay, great. And within the motion behavior, we got multiple controls. So we got the motion frame, so at which frame of the motion we are at, motion time. So that's going to be the same controls, but expressed in time, at also motion ratio. So motion ratio will probably provide a value between 0 and 1, or maybe more. So let's see how it looks like. So once again, I'm going to copy the name of, let's go back to false here, so we don't have the same problem than before. I'm going to copy the name of that behavior, put it from here, put it there into the attribute. Okay, let's remove those brackets. Great, and connect it right away into the behavior. So let's take a look at what we have in the graph. So we can see here we at ratio 0.21, and then you can see that the ratio moves in more and more and more and more and more. So it means that if we want to play that motion 200% time, it means that we need to have played that motion twice. So 2 times 0.6, 2.6 means that the motion has been played 2 times 0.6. If we want to convince ourselves about it, we can take a look. That motion here, for example, is 31 frame. So we could look at frame 31 or 32 or something like this and see what's the current value for this. And we can see that we've been running that motion for almost in its entire duration. And which what also works properly is that if you provide two different motions there, so for some reasons my assets, they're not connected properly. Never mind. Golaem motions, and let's grab maybe another clip here, like a motion clip and a walk slow animation. So here now we're having two animations, one which is 31 frame and one which is 54 frames. And depending on which motion gets assigned to which character, we'll have the rate ratio being written on. So now you can see that it's not this exact same value for every single characters. You'll notice that the characters which has the slowest, the shortest animations, the ratio plays faster than the one where playing the slowest animation, the longest animation, sorry. Great, so let's use that motion time once again, that motion ratio. Once again, let's put a Boolean operator. Well, you know the drill, right? So I'm going to put if this is superior to a specific constant value. So my constant value here, rather than 200%, is going to be 2 because it's a ratio. Set it up to double. And I'm going to use this to drive the end of my behavior. So let's close all the stuff we don't need. Great. And now, depending on the motion, some characters will end up earlier than others. And after they've been playing the motion twice, they just stop. Now let's tackle the script trigger. So just a bit of warning within that trigger. Obviously, what will happen if you use that trigger is that the code that you're going to put into it will be evaluated for every single frame for every single characters. So it may end up, being really computing heavy. So I would really recommend not to use that trigger, except if you don't have any other alternatives. But I would say with all the ChOps approach, probably now there is no big meaning about using that trigger. So it probably will be deprecated at some point. But yeah, once again, keep in mind that really we don't advise this because we're gonna, execute some Python code or mail code on the fly for every single character at every frame, and obviously it will take a lot of time to process. So here what I did, I wrote a single piece of mail, pretty simple, but it will apply to Python as well, right? So I'm just having a function called scene currentFrame is equal to, takes a parameter which is a frame and returns an int. So it's really important that all the functions that you're going to use into the trigger attribute will take will output a int value. So mail only support int, but with Python you can export like an int or a Boolean. So what it does, it takes a parameter here, it evaluates the current time in Maya, returns it as a current frame, and we're going to compare the current frame to the frames is set up to parameters. So I want to source that function. Either I put it into my preps or any script which gets sourced by Maya, or source it from here. And I can just check if my function is working. So is the scene frame is equal to 10, return 0. If it's equal to 15, returns 1. So probably works as expected. So within my mail trigger, I can copy paste that call function. Specify that here the language I'm going to use is going to be mail. And if I run my simulation, I will have my characters at frame 10 who are going to move. And obviously if I change the parameters here, now it's frame 50, my characters won't move until it reaches frame 50. Great. So obviously, yeah, I could have used the current frame trigger here. I just wanted to keep it like super simple in terms of example, but you can evaluate whatever you want to within Maya. Right? So instead here, I'm going to enable that behavior there, go into the ChOps for just a minute. We'll go into the motion. We're going to disable the motion behavior. And as always, go into the ChOps and see how we can reproduce this. So always starts with an input. And you may have noticed that within the input type, I've got multiple entries, and one of those entries is apparently mail or Python. As soon as I said those, you probably noticed that my expression that I put here, it's still there. So this is probably where I need to write that data. So once again, I can just put my piece of text here, and just if I press enter, it will open the old attribute. So if I want to validate that field, I have to move to a separate entry here. So I'm going to specify here it's a mail code and connect it together, and we're going to be done. So here, once again, we're going to have everything being evaluated. So here to evaluate that mail code for all the characters, and as soon as it's switched to 1, that was pretty like quick, but let's go to frame 50, which was the value, and set it up into the trigger. Now it returns 1, the attribute returns 1. So if we were about to have that motion behavior at frame 50, all the characters will turn into that walk animation. So that's for mail, but also Python does the same thing. You can call any function which will return 0 or 1 and write it directly into the attributes. If it doesn't return 0 or 1, you know, you can just compare it to some Boolean operation and do your own stuff if you don't want it to do it into your own function. So yeah, let's see the next one. Okay, let's now address the fade trigger. So the fade trigger is more like an operator than a trigger, but still has sense into the trigger library. So here, let me probably walk you through the process of that ramp node. So it's more or less used to delay the result of previous behaviors, but here I can use it also by its own. It's not a big problem. So when you open it, you've got two kinds of control. You got something called the duration, which is a frame controller. So here it tells us that here, that duration here on that axis represents 60 frames. So what we're going to do is we're going to sample that space as 60 different slices, and every time a new frame comes in, we're going to move into the right side of that ramp evaluation. Okay. And that ramp curve that we're having, that value that we're having here, is at every frame is the probability that, it's the probability at which a character will be able to start that motion. It's the probability at which a trigger will be returned true. So when we are really low here, it means that probably 1% of my crowd will return true, and then that's 2%, that's 3%, 4, 5, etc., until we reach that value there, and that value here, which is 100%. So it means that it's cumulative. So it means that on 60 frames, some characters may end up here, some characters may end up there, etc., etc. And the more we move in time, and the more characters has chance, and the more character will start walking, until when I reach the end, I want all my characters to actually be able to walk. If I don't want all my characters to be able to walk at the end, I'm not having to put that 100% value. I can just set it up to 0, and there's some situations where some characters, maybe some unlucky characters, especially if that curve is pretty low, may never start that animation. Well, let's check how it looks like when I do something like this. So for the first 60 frames, we're going to evaluate a probability, and you notice that here I reach a value of 116, and there's one character there in the background which hasn't started. But still, there's still a fair amount of characters which has started, because for 60 frame, we throw low value, while it's still 10%, right? So let's probably provide a lower value here. And that gives you a sense of what that behavior, what that trigger is able to do. And as soon as we pass that 60 frame threshold there, no more evaluation of that ramp happens, so we're sure that those characters here will never switch to the walk state. So if I'm on the opposite side, if I set it up from the end of my curve to 100%, I'm sure that between frame 55 and 60, all my characters will turn blue, even the one which were green before. So that gives you an idea of what's going on here. So we're going to evaluate a curve, so based on specific frame count, and that gives us a probability to go through based on the entity, right? So let's see how we can reproduce this into our channel operator graph. So in 8.2.2, we've been introducing two different nodes that we're going to use here. One is called the ramp. And as you would expect, it's probably where we're going to draw the exact same ramp than the one that we had before. So let's start with this. You notice that that ramp That ramp here doesn't have any duration attributes, so that's going to be your goal here to define what's going to be the input there, and what's going to be the output here. So it has indeed controllers about the input, so minimum input and maximum input. So it means that how much is this on that axis. So right now it's 0, and where is that position there? So right now it's 1. Remember, in our trigger, we set it up, it has a 60 frame duration, so probably we'll have to set it up between 0 and 60 or something similar. So how do we do this? So first, the first connection which goes in here, so let's plug just a various input here, is going to be the value at which I'm going to evaluate my frame. So just so I can show you exactly how it works, let's put some value there. So if I put a driven attribute of, let's say, 1, for example, so it means that we're going to look at the value of the curve at 1, and remember my input space is between 0 and 1, so 1 is going to be this value here, and this value here will return 1. Let's check. So if I run that simulation, select that guy here, this one return 1, it goes into the curves, into the ramp, sorry. Ramp gets evaluated, what's the value at axis 1, it returns a value of 1, returns 1. Okay, let's say the input is between 0 and 2. It now means that 1 is going to be more or less at the middle of the ramp, and the value which is get returned is some really slow, super slow value, which is probably right here. Got it. So as a sense, if I set it up to here, now I go back to the end of my ramp, because my ramp is between 0 and 2, and it returns 1 again. Well, I guess you understood the idea there. So as we want something which moves through time, we need to plug that entry to something which is dynamic, right? So in the previous examples that we had, we were using the current frame, but what if that behavior, I don't know, starts at frame 100, and we want to count from 100 to 0 to 60, well, if I'm using the current frame, that will be too late, right? So we also introduced another node, which is called the counter. So counter is going to be here. It has a start, stop, step attributes. So it goes from 1 to 100 by default, by step of 1 frame. So now if I plug it here, so once again, it goes from 1 to 100. Right away we'll be out of the ramp curve evaluation, and probably it's going to return 1 all the time. So even if the value moves here, we can see that we are not evaluating our curves in the right proportion. So now I need to say that my axis here is not going to represent a value between 0 and 2, but it's going to represent something between 0 and 100. Well, no need to redo this exactly on your side. Really, that's just some testing that I want to show you at the moment. So now if I do this, now I have my value which is climbing up the curve. So now my axis is going to be represented between frames 0 and 100, and now I've got a counter which is increasing value, and I can see that it's following my curve until it reaches the end. It probably return 1 at some point when we are around frame 100 or something. And here we go. And it goes modulo, so it means that when it reaches 100, it goes back to 1, so we reprocess the curve, and so on and so forth. Okay, great. So what if I want to set it up to 60, between 1 and 60? So as I said, I can change the value here and there, and I can change the value here and there, but it may be, pretty common that you think about changing the value somewhere because you need to reevaluate something. Or you need to refine your ramp and have it evaluated between another range, and you forget to change it here. So instead of putting some hard values here, what I can propose is put a specific node which is going to be my mean bound. So let's name this mean bound, which is going to be between it's going to be a double value of value 1. So that will be my counter min, but also my ramp min. And let's create another entry which is going to be double, and it's going to be my max bound. And now I'll just have to change the value once, and hopefully have it everywhere, the right values there. So that's going to be 60. Remember, I had my ramp in my trigger between 0 and 60. So what I can do is plug this mean bound to my chop counter, you can see that start and stop now are disabled. Now they are being driven by that node and that node there, so that's great. And that's exactly the same for the ramp. If I connect that min bound to the second entry of the ramp, remember that the first entry is going to be what's the access value we want to read here. It will be the input min. Now we can see, well, it's supposed to be blanked out, but never mind. So now we've been connected two values. You can see that input min and input max has been grayed out, so which means they are not controlled by those attributes there. And now the more we move in time, you can see the counter is moving as well, which is moving also up through the ramp and providing up some values there. We may not want to do the modulo. So the modulo is just, going back to the first value of the counter when it reached the end. So maybe something we want to do is disable this. So when you reach 100, it keeps giving back 100. Wait. Step output is, okay, there's probably an issue here because it's supposed to follow the bounds I've been providing, but it's not. So if I don't modulo, okay, sorry about that, I'll have to probably check the code. Okay, well, never mind, let's go to modulo and let's assume that in the version that you'll have, it will be working properly. Anyway, okay, so great, now we've got something equivalent to the ramp evaluation, right? We've got something which is returning a value, but at some point here we need to compare that value with something, so it has sense in terms of every single character compared to each other, because here that's the same value for everybody being returned, right? So probably we want to have a way to compare this. So what we can do is, as it's a probability here, what we can do is, here it's saying that 10% of the characters are supposed to run through this. So either we can do something like we did for the random trigger. When we operated the random trigger, we assign a random value, put this into a buffer, and use this to do a comparison. That would work. But I just wanted to show you something different here. So here, what I will do instead of taking a random value being picked per character, what I can just do is look at what's my index for my characters. Once again, remember the index is just going to be a value between 0 and EntityCount. I want it to be, I also want to bring, let's provide some names. So that's going to be EntityIdx. There. That's going to be EntityCount. So EntityCount will return how many characters I'm having into the scene. So there's going to be a channel there. If I look for count, I'm having EntityCount available. And if I divide my index by my count, it will give me like a ratio between 0 and 1, and that ratio can be compared with my curve, right? So let's divide this here. And well, let me show you what it looks like. So if I connect this and run, so here I'm having 60 characters in the crowd, so that's my right number. My ID is 38, so I'm going to divide 38 by 60. It gives me a ratio, so whatever. If we look at the numbers that we get here, we get various numbers. So obviously the lower character, the lowest the value, and the higher the character, the higher the value. Great. So what we can just do is compare. So now we've got a value between 0 and 1, which is different for every single character. So what we can do is compare it to the probability that that trigger returns true. So let's put a Boolean, once again, a Boolean trigger there, Boolean operator, and we're going to ask if this ID, which is not moving through time, is inferior to my ramp probability. And now we can plug this to my motion behavior, re-enable the motion behavior, and we'll notice that here for the first 60 frame, all the characters will move to a specific motion behavior. There's some characters which are not going through this. Let me check what I did here. Okay, So there's my ramp here, which is probably I need to have, okay, as it's not modulating. Yeah, okay. Well, that's probably okay. This still related to the fact that I had that modulo not working properly. So I had my ramp, which was restarting back or going through not the right value. So you know what? I can actually go into that ramp, kill that node there, and just say that I don't want to modulo that counter. So whatever, that will just let my characters go through this as well. And if you find it a bit brutal, the way it's evaluated, you can change the shape of your ramp, do something like this, like propose, you know, more granularity in the way it's being solved. And now you get something which is more delayed. So now you've been reproducing the ramp trigger. So for sure it involved way more nodes than just the ramp. But once again, it's way more flexible in terms of what you want to do. Here, instead of evaluating an EntityIdx compared to whatever, you can compare it to something else. That bound system or that evaluation system, it has not to be bound to a frame. So in the trigger, you specify how many frames you want to have, and this is what defines how long it takes to fade. It can be different. It can also be different per character. Here, I'm providing the same values for every single characters, but it can be also like tweak on a character base, maybe based on the type or whatsoever. So once again, give you more control and more power over your triggers if you want to. Okay, so now let's switch to the trigger operators. So there's 5 of them, and now we're going to tackle the 3 first. So we got the AND operator, the OR operator, and the exclusive OR operator. So those operators require to have entries. So the AND operators, for example, can have as many entries as you'd like. And what it does is it looks at all its entries, evaluate all of them, and if at some point all of the entries return true at the same frame, it will return true by itself as well. If just one of those is not returning true, but all the rest is returning true, no matter, it doesn't change anything, it will just return false. So it has to fulfill all the conditions at once. So in that scenario here, what I've been doing is I've been looking at the time saying that I want that trigger to return true when we reach frame 20. And I also looked at the index of my character and just asking for that index to be below 30. So below 30 means that I want half of my crowd because I have 60 characters here. So when simulation starts, I'll notice that this character here, for example, let's click on him, is entity 2001. So probably his index is 3. So 3 is below 30. So this is why we've got that block here, which is green. So that's expected, but you can see that the AND door for now is not returning true because we're not at frame 20. If we go and reach frame 20, now you can see that those two those two triggers, sorry, let's redo the process. Those two triggers are green. I have the green sign next to them. And obviously the door now has all the previous triggers return true. That door will return true. And now I have all my characters switching to that walk animation. Great, so this is for the AND door. Let's change the scenario and use the OR operator. So operator compared to the AND will just look at all the entries, and if any of the entries is actually returning true, if only one, or if it's more, but that's a good situation as well. But if at least one of the previous entries return true, it will return true by itself. So we would expect that when the simulation starts, some characters will return true right away because their index is below 30. So we'll have some characters starting to walk, but also at some point the frame that we're going to reach is going to be 20. So the rest of the characters will start walking by themselves as well. So now we've got a different scenario than the previous one where all the characters are actually walking independently from the index, because at some point at frame 20 we wanted them to start walking. And finally, we got the exclusive OR. So rather than connecting the two nodes together because it won't make any difference, I just want to show you with another scenario here. So here I want half of my crowd to move in, and I also connected a true trigger. So here the ID is the exclusive OR will look at the entry. It's more convenient if there's only 2 entries, and what it will do is it will look at the fact that there's at more 1 previous trigger which is returning true. If there's more than 1 trigger returning true, then it means that it won't return true by itself. So for some characters here, remember my character, which is here. Here you can see that that trigger returns true because he's below index 30, and then that trigger also returns true because that trigger is always return true. And you can see that the door is not returning true by itself. The operator is not returning true by itself. So what we'll have is we'll have the opposite here of the crowd. That guy here, for example, his ID is 52. 52 is above 30. So that trigger, which returns true, will go into the door. The door will say, okay, there's at more 1 previous trigger, which is returning true. So all good for me. And let's go. So this is the exclusive OR. Great. So let's see how we connect this to how we relate with this with a chop. So I'll go into my chop graph once again. I'm going to reproduce the same system that I had. So this is going to be my current frame. So I'll redo something that we've been doing in the past, right? So we're going to look for the current frame here. We're going to put a constant, which is going to be our constant 20. Oops. Okay, let's say it's going to be a double value. Put a value of 20 here, and what we want to do is use the Boolean operator to do equal, right? So now I've been creating my current frame trigger, and if I plug it here, just for the sake of it, I'll just run my simulation. Oh, and for some reason here, my characters, they are not switching. So this is current frame, right? Let me check what happens. 9, 10, 11, 15, 17, 18, 20. Output is 1. Output is 1 here. And, oh, sorry, okay. Sorry, my motion behavior was disabled. So, okay. Now that's expected. So after frame 20, my character start working. So all good. That's my current frame trigger. So this is that node here for the matter. Okay, let's do the other one here. So let's compare the index and make sure that it's inferior to a specific value. So now I can bring a new entry, called it EntityIdx, and I will grab the index from here. I can say, oops, I can say it's a channel, but well, I can stick with the default mode, doesn't make any difference. And now that's going to be my constant 30 there. Whatever, say it's a double, 30 here, and use a logical operator, Boolean operator, to look if it's inferior or equal. So I'm gonna look if my ID is inferior to equal to 30 and connect this to my output trigger, output attribute, and now we can see that half of my crowd is moving, all the characters which are concerned by below 30. Great. So now we've got our 2 blocks here. So what we want to reproduce is that AND door. So once again, the AND door can be defined into the Boolean operation. So Boolean operation are all the operations which just return 0 or 1. And if we look at the end of the list, well, you probably figure most of it, right? There's AND or XOR, and there's the NOT as well. We haven't spoke about the NOT yet, but probably it can be included into that chapter. So we got all the same operator, right? So we can put an AND here. So that Boolean operator takes as many entries, such as similar to the AND operator, which is here. So now I can connect these two together and wait for frame 20. And now I can see that all my characters move from one point to another. So this is the AND door. Then I can say or we'll just have all the characters below 30 to start moving, and after from 20 all of them moves, and XOR, but once again I will have to probably connect a true trigger like I did before. Great, so let's now tackle the NOT operator. Okay, let's tackle the not trigger operator. So the not trigger operator compared to the others only take one entry, and what it will do, it will invert the result of the previous entry. So let's say I put that not operator here, rather than looking for the characters which have an ID below 30, we're going to look for entity index which are going to be superior to 30. So probably here is not so convenient to use it here because we could have just switched the operator to superior, but in some situation it has maybe more meaning, especially when we're using the zone rather than checking if we are into the zone. Maybe something we want to do is we check if we are not into the zone. So connecting the output of the trigger zone to a not will invert that result, and you could check if you're out of the zone rather than within the zone, which is not something that you could do here. So this is the whole purpose of the not operator. So now you notice that, yeah, and this is the end door, obviously. So now you notice that the characters which are switching to that walk animation are only characters which are having an index superior to 30. If I were about to remove this, you notice that the people who are going to walk are going to be different here. So that guy here, for example, has an ID of 25, index of 25 or 26, which will be below 30 there. So this is what the not operator does. So if you were, to grab the previous graph that we had before, let's re-enable this, for example, and reset this to an end door. What we could do is introduce a Boolean operator here and just set it to not. So here we'll reproduce exactly the same setup that we had, only the characters which has an index which is superior to 30 now are playing the walk. So in that situation as well, the not operator just expect one previous connection. If you were about to put multiple previous connections, they will be ignored. And finally, let's talk about the last trigger operator, which is going to be the accumulator. So here I put an accumulator sequence right after a painted zone trigger. So the idea of the accumulator is that you're going to put a count here, and it's going to record how many times the sequence before returned true, and as soon as that count, well, that amount of true being returned to the accumulator reach that threshold, which is here, the accumulator will return true. Notice that you got a checkbox right behind, which is telling you that if you check this, it will reset the accumulator count on false. So if at any time, it means that if it's check, if at any time you go out of a specific color and that sequence that you had before returns false, it will reset the current count and you'll have to reach that value again. So here, keep in mind that it's unchecked there. And if I run my simulation, I'm going to check if I'm within a red zone. So you can see that even if the characters are within the red zone, they haven't turned into the next animation here because they haven't reached it like 100 times. And as soon as they reach it 100 times, now you can see that they switched the run animation there. So those characters here, for example, they don't spend 100 frames into that red zone. So this is why they are not, moving. Let's say we were putting a lower value here. We'll have to wait for a lower amount of time before we can see the characters transitioning to that run animation. And finally, let's go back with 100 here and say that we want to check out that box reset accumulator. We'll probably notice that no character will switch to the run animation because as soon as they go out of the zone, it reset the counter to 0 and they have to recount until 100 and they never reach that amount, so they never switch to 100. Great, so let's see how we translate this as a chop. So what I'll do is I just disable that graph motion for the moment and jump into the chop animation, the chop graph there. So amongst all the operators that we have, there's an operator which is called Accu, which is standing the short for accumulator. It's working slightly differently from the one that we have into the triggers, but we'll just walk through the various parameters here. So first we've got a mode. So mode by default is average. So what it does, the mode takes the number of previous values. So Accu size tells you how many values you want to remember. First in, first out will tell you if it's going to be the last values which are going to be input by the sequence which are going to be remembered, or the first one. So if I uncheck, it's going to be the first one. If I check, it's going to be the last ones. And average will just take all the 10 values that you've been accumulated and will just return the average value. So if you just have only ones in it, it will just average it and return ones. That's not exactly what we need, right? Sum will, contrary to average, will take all the values and sum them together and return you with the results. So sounds like more that's something that we want to do. And there's an enable Accu, which is probably gonna control if you want to accumulate values or not into the system. Great, so let's sum those. So for this, we're gonna, as we've been doing, reproducing that painting zone locator. So I want to search for color. So I want to remember what's the painted color, and well, I want to reproduce exactly the same setup when I was doing the video about reproducing the color trigger, right? So I'm gonna just copy the name of that painted zone here, put this into my attributes there. So let's specify it's gonna be a channel. I want to compare it with red, which is the same thing that I've been doing. So this is going to be const red there. The value here is going to be a vector. So it's going to be red, green, blue. So here I'm comparing this to a red. I want to make a comparison. So here I just use the equal operator. And I want to sum this into my bunch there. So what I wanted to do is say that I want to have an Accu size of 100. So I want to remember 100 values there and put this into the trigger output. So the really fancy thing here is we're going to be able to, oh, yeah, right. I actually need to have my characters move, obviously, and set the default trigger to false. So have them walk. Great. So now that that character is in here, I'll be able to check for that character what's his value, and I can see that here the value is currently red. So the result of the operator returns 1, and we put this into the accumulator. And we can see that we are accumulating various value, and at the moment we've got 10 values which are accumulated. So if I run more, you notice that it just filled itself, and then the character goes out of the zone, so we just returns, and now it fills with 1. So okay, that's great. That's almost good. The thing is, you notice that my buffer is only 100 frames here, so that's not exactly what I need. If I want, so here the use case I'm having at the moment is that reset checkbox set it to 0, so unchecked. So it means that my counter resets itself as soon as the value reaches 0. So obviously this is it's a use case that we may want to use. So just let me sum it up here. So if the accumulator has a checkbox set to false here, it means that we don't want to take into account the fact that as soon as I go into the zone, we want the counter to be reset. So this is the setup that we have here. So to convince ourselves, what we'll do is we're going to enable this trigger here to say, okay, you're going to switch from the walk animation to the run animation as soon as my attribute gets to 1. And what we want to do, obviously, is to compare it to a specific value. So we want to compare it with, let's say, 100. So we're going to have a constant, once again, which is going to be our threshold, constant 100. And we're going to compare if those two values is equal. So if the sum of my accumulator equals 100, then I want my trigger to switch. So probably 100 is not the right value here. By the way, I didn't set the value there, 100. And also, by the way, if you here, you know, the thing is I'm gonna have to change the attribute twice, both in the constant and both in the accumulator. Something I can also do is connect more nodes to the accumulator. you'll notice that as soon as I connect a new node, the Accu size is not being driven by that attribute anymore. It's going to be driven by this here. So let's call this like constant threshold instead. Okay, and we're going to put just a value of 50 at the moment. So let's just check that we can get 50 times that animation running, and as soon as the characters, get out. So now we're good. So by doing this, what we've been reproducing is accumulator 50 and reset accumulator on false being checked. Because here, at any moment, if the characters go out of the zone, it will write another value into the buffer, and that buffer obviously will contain a 0 at some point, so it will never reach 0 if we not always are into that zone. So let's say we don't want to have that reset accumulator on false. The only thing that we have to do is set up a big enough value. So we're going to break that link here. So we can put probably 100 here, and maybe what we can do is something like multiply that threshold by, I don't know, 2 or 3. So we can have a, oops, that's not the right operator. Sorry, that's mathematical operator that I want to have. Let's connect this here. Say that we want to multiply this by maybe 3. So now we'll have a buffer which will be big enough. Double 3 here. Let's rename this const 3. And let's put it into the accumulator size. So now that what we're saying is we want to have 100 values available into a buffer, which is 3 times 100 values, so 300 frames. Here, if I want to be honest, my sequence is 500 frames. So if I want to cover all that happens into the sequence, I should probably like have the same number than the number of frames that I'm having. And now, if we run that simulation, we'll have characters walking into the red zone, but they don't walk long enough, and then they go out, and then they go in, and at some point they just switch into that run animation because they've been accumulating both walking into that red zone here and both walking into that zone there. So yeah, we can see here that we've been accumulating way more than 100 frames, and now it's been switching the animation. Once again, using a graph, chop graph instead of the trigger will give us way more control on top of what we need. If we don't want to have the same accumulator value for all the characters, that's also something that we can modulate based on, I don't know, an index or a random value that we'll handpick. We've been seeing at the beginning of that video how we can reproduce a random picking for characters, like picking a random number for characters. So that's also something that you can do and influence this, so we can have various values per characters and various behaviors for characters if you want to have a different setup here than the default one, which is provided by the operator. And that concludes that trigger to chops video. Hope you enjoyed it and that helped into figuring some stuff out.